Hi all, my name is Frida and I am head of the group Connected Intelligence at Scania R&D. The group name and constellation has of course changed a bit over the years, but we have been a key component in Scania's evolution of data-driven product development for over 15 years, working with data from connected vehicles. Today I want to share with you some of our learnings that we have accumulated over that time. I would like to start by giving you some perspective on what 15 years mean. To me, myself, it's basically an adult lifetime. Today, almost to date, 15 years ago, I graduated from high school. I have since then earned 2 academic degrees, worked for a decade at a handful of companies and a handful of positions, and had a daughter. That is, of course, also a journey, but today I will focus on the knowledge that the collective mind that is connected intelligence has gained over these years. Almost all Scania vehicles are connected today, and we work with enormous amounts of data coming from those vehicles. I can quantify enormous for you a bit. It means, for example, that we collect fault codes and operational data, the way that a workshop does with your own personal vehicle, both in workshops, but also remotely since 2005. And that is possible through the black box that you see on the picture to the left. That data set alone adds up to more than 100 billion rows of data with the dimensionality of more than 5,000 variables per row. And this distributed over a population of over 1 million vehicles. And the black box also makes it possible for roughly 500,000 vehicles to continuously stream geospatial information and operational data since 2011. And that data set today reaches about 70 terabytes of information. The people in the group are, depending on what year they were employed, statisticians, analysts, data scientists, machine learning engineers, or big data visualization artists. We work with data warehouses and lakes, streaming analytics, cloud environments, and all sorts of data mining and machine learning you can think about. With this, we enable data-driven product and service development internally at Scania, as well as deliver insights to end customers. A challenge that we face daily is how to create true value in our hyped domain. I have spent complete talks on speaking about the most important thing for this, and that is to start with an actual business need. I will not deep dive into this now, but please trust me on that one. Today I want to focus a bit more on the technical side and how some foundations that we work with stand strong over trends and buzzwords. So let me start with the largest contrast we could ever have to a picture of cool dashboards. Standardization and structure is great fun. Standardization and structure is something that the automotive industry always has been strong at. And I believe it's one of our biggest success factors to enable a data-driven product development over more than a decade. A standard example is, for example, J1939, the recommended practice used for internal communication and diagnostics among vehicle components. Another is the Fleet Management Systems Interface, or FMS, which is a worldwide truck manufacturer standard to vehicle data of commercial vehicles. A standard sets a foundation and a common language internally in the software of a vehicle, as well as between different vehicle manufacturers. But maintaining and making good use of a standard to get the full leverage of it is not as easy as distributing a document. A learning is that it's a constant good cop, bad cop operation and an underground infiltration of the development process until it's a natural law to follow the standard with a common interpretation. At least that is at a company as Scania, where developers have a great deal of individual freedom. This culture has a cool duality. It's a challenge to make something work seamlessly, but when you do get followers, a great concept soon becomes an avalanche. This flowchart depicts how a lack of common interpretation poses challenges and shows how we handle exceptions among electronic units when there is no standard for communicating exchange as different from update. Another, perhaps more intuitive example on concrete operational data that illustrates when you need the good and bad cop behavior is, for example, ambient temperature. Imagine that the standard says how and when a certain chip could store information from control unit into the memory. And this could then be collected through a remote or workshop diagnosis readout, as I explained before. What data that should be stored is up to the developers on that chip. And that chip we have as an example is connected to an ambient temperature sensor. The developers themselves want to know the max ambient temperature a population of vehicles are operating in, because this makes it possible for them to source the right tolerance for their components in a later generation. Then the max temperature is what they will store. However, if we coach them to instead store the operating hours in certain interval buckets for ambient temperature, a complete histogram of any vehicle's operating conditions can be used to answer other questions as well. And that is with only a few more bits of storage being consumed. So you can easily imagine the same use case for any other very intuitive actuator, such as the rain sensor. And this is what we work with for all sensors and all types of operational data. So I want to show you some things that fully implemented standards have enabled and show you how a stable foundation of information and structure has made us fast-moving when it counts. We've had a really cool collaboration with Heavy Logistics to reduce emissions in the McDonald's supply chain globally. Operational data from previously Heavy-owned vehicles has been used to tailor the greenest and most economical solutions on each market. And connectivity and FMS continuously make it possible to follow up and optimize utilization and performance through maintenance. In product development, the best possible innovation culture is when you just can get an idea and test it reasonably fast or even instantaneously. For physical products, we have a climate tunnel on site in Södertälje. It was a large investment, but something that has reduced testing kilometers needed vastly, and as a result, also the fuel consumption with the release of the latest Scania truck. Data gives us the same possibility, and similarly, an idea about data-driven retarder oil replacement could be taken from idea to product in a matter of months based on already existing data from over 50,000 vehicles. So connecting standards and maintenance back to buzzword reality of today, I think you all have heard about digital twins. This is, in my opinion, just a fancy word for standardized interface. But speaking of interfaces, my second thought I want to share with you is that you shouldn't fear a layered thinking. That is actually a way of showing proper respect for different domains. In my experience, IoT tends to erase boundaries between cloud and sensor. But these two areas are too large domains for anyone to create really good applications when you're beyond that trivial example of one sensor connected to one application. Taking a smart bulb from Raspberry Pi to app makes it easy to underestimate the challenges in creating a complete solution filled with integrations and intelligence. I see that my group often have a translator role between several domains, as explained by the example in the picture, where our role is to develop anomaly detection methods that can be applied to multiple sensors for multiple applications. To develop a capability taking data to information and insights, we touch both the domain of onboard embedded development, as well as web development, a bit of service development, and business development as well. We need to understand input data where anomalies are formed. This, for example, to be able to apply statistical models that comes with a prior. We need to understand how to make the results available for services that want to display the anomalies. And usually we will need to make a capability like this generic enough to match multiple use cases. For example, in this case, anything from an in-vehicle app showing anomalies to a driver to an interface for our field quality department where anomalies would be clustered and aggregated for further analysis to detect faults early. So we are truly cross-functional when we work, but always try to communicate and set clear boundaries for what will be our responsibility or layer once moving forward with the solution. There are marketing theories on underfitting or overfitting offers for a customer, and I believe they are very much applicable for interfaces and capabilities. We try to create information and insights that we are able to reuse for multiple use cases, which is a good investment when they take more development effort than one team over one sprint. I have myself worked as a developer in all kinds of pasta, and arguably spaghetti will always be the worst. But I'm not sure that the ravioli fad diet of the last decade always is the way to go for the more complex IoT solutions. So just to make things clearer or possibly unclear, I will have to explain that I'm mixing a bit of architecture and organizational thinking when I talk about layers. If you purely talk about structuring code into small, independent, self-contained pieces, then I have few arguments against microservices. But I have experience of reduced productivity and a lot of challenges in microservices becoming a political argument for not dealing with unclear responsibilities. People claiming that domains must be completely set free to stimulate innovation. That means that everyone tries to make the most prestigious ravioli or app using the same shiitake mushroom. And there's no perspective on how the complete dish should come together, since there are no expectations on what will be delivered. Clear responsibilities are a top-down and bottom-up continuous dialogue, both in the kitchen and in research and development. And I think that is one of the most key responsibilities for leadership in this domain. So therefore, I claim that my current favorite pasta is lasagna, and that the layered platform thinking is an investment that is worthwhile when you develop complex applications. Finally, my third and final advice for how to build a great foundation for a data-driven company is to automate everything important. IT development is production, and deviations should be brought up, and any room for manual mistakes should be avoided. This is a foundation for Scania's excellence as a product company and a successful philosophy to lean on, pun intended if you get it, also as an emerging software company. And it's possible to implement a thinking similar to production by living and breathing test-driven development, DevOps, and immutable infrastructure. We work with this mindset in our data pipelines, but I think the best way of convincing you about the benefits of automation is by looking at the history of our data collection. In 2011, the black box you saw before was introduced as standard in the vehicles, and a freemium offer that automated data collection was made possible to sign for all customers. This is how the population of streaming vehicles has grown to 500,000. As for diagnostic readouts per week, they were sent in on paper before 2004. In 2006, it was possible to call individual vehicles and get information by phone, a highly manual process. In 2011, the readouts were automated for workshops visits, and in 2013, remote manual readouts were made possible. In 2018, we had the last addition to this, which was automated scheduling of the remote readouts. To me, the power of automation is obvious when you see the changes of inclination in the curves I've just shown you. We have automated our data collection and thereby giving us a foundation where we now can focus on the use cases and the business value. So the analogy of truck production is also possible to take with us in the future. What we have done by going from a product-oriented manufacturer that connects vehicles and offers services that guarantee uptime, remote updates, etc., is the same thing that we can do when we introduce monitoring and updates of models and pipelines, or so-called data ops. We build our relationship with our IT services that last beyond deployment in an unknown server somewhere in a hidden on-prem basement. The same way as connectivity and services maintain a continuous relationship between Scania and a vehicle owner. So, standards, organizational responsibilities, and a service development that is compared to production. Surely you must at some point down the line of this have been convinced that we work in a rigid, old-fashioned business and that the prime time for Scania's data-driven innovation is behind us. I'm glad that you stuck around so I can rid you of that perception. The truth is that we've actually just started. All the examples you have seen so far has been with a clear product focus or on an individual vehicle, but the world is larger, more cross-functional, and more integrated than that. And if we zoom out even more, it is apparent that we are a part of a system of transport and logistics. That system is clearly defined by the data that we have at our hands. As you can see by the traffic flows depicted for one day in Germany. Or the yearly fuel consumption from Scania vehicles only in the Netherlands. Information like the one you've seen right now is a key component towards electrification and automation of yesterday's transport system into a modern, more sustainable one. And I personally believe that innovation should be given loads of space and time, but also the tranquility and problem-solving spark that comes from frames and boundaries. Today I've told you about the way we have worked in the past and will continue with in the future. And if you're curious about how we meet the future challenges I have brushed upon, I highly recommend you to listen in on the talk of my colleagues Gustav and Verish later this afternoon. So thank you a lot for listening, and reach out to me if you want to have any follow-up discussions. Q&A is normally my favorite part of having an audience. Bye.